Today is Tuesday, March 17th, St. Patrick's Day, 2015. We're going to continue where we left off yesterday on example 5, which is on page 309 of your textbook. We talked about so far how to complete the square, and these last two examples are about how to complete the square when there's something in front of the x squared term. So, as a refresher, to complete the square, first you better make sure your quadratic is isolated so that your c value is over on the other side. And then you got to take half of b, then you got to square that, and then you add it to both sides of the equation, and then you factor it into your perfect square binomial. And so it should be x plus something, close paren, squared equals something. Then you root both sides, and you get that something equals plus or minus whatever the square root of the other side was. And then you solve twice. Okay? That's the basic verbal rundown of what we learned yesterday. Today, we're going to learn how to do it with a 2 in front, or what happens when we have solutions that are imaginary or complex. So I is going to make an appearance again. And I've missed I, so that's good. Alright. Example 5 is about halfway down, or a little less than like a quarter of the page down, or quarter the way down the page. Okay. And it says, equations where a does not equal 1, and again, a is the coefficient of the x squared term. Okay. So it's as simple as you might think, except whenever you have an a term that's not 1, you're always going to have some kind of a fraction. And that's just something you'll have to get used to. So our equation is 2x squared minus 5x plus 3, and we got to complete the square. But notice, it's not just x squared anymore. We've got this pesky 2 in the way. So we have to get rid of it by dividing it out. Okay? We have to divide each side of the equation by the coefficient a. In this case, that's a 2. Okay? Because 2 divided by 2 is 1. That's the whole reason we do it. But you have to remember that when you divide out the left-hand side, okay, you have to put it with all the terms, not just the first one. It doesn't just cancel. Okay? So, for instance, when you divide 2 out of x squared, or 2x squared minus 5x plus 3, you actually get x squared minus 5 over 2x plus 3 over 2, and then equals 0 divided by 2, which is 0. Okay? So again, when you divide out by that a term, make sure you divide it out of all the quadratic parts, not just the x squared. You gotta put it over 2 in the x term and over 2 in the constant term. So that's why we're left with x squared minus 5 over 2 x plus 3 halves. Okay? But then we do the usual procedure. Once you have those fractions, don't get freaked out, they're just numbers. You can still move them about the way you're used to. So to start the whole process of completing the square, you have to move that c term over. We have to move that positive 3 halves over to the other side. So to do that, we subtract, okay, and we have x squared minus 5 halves x equals, and then of course negative 3 halves, because 0 minus 3 halves is negative 3 halves. And now we start the actual process of completing the square. What's the first thing we do?
Half the b term.
Right. So if b is negative 5/4, or excuse me, I just told you the answer. If b is negative 5 halves, half of that is negative 5/4, because you're just dividing by another 2 in the denominator. 2 times 2 is 4. Okay? Whoops. Okay? So again, you take half of it is negative 5/4. Okay? That's the first step. What do we do to that negative 5/4?
Square it.
Square it. What's negative 5/4 squared? Pardon me. How do we square a fraction?
25.
Uh-huh.
4/16.
Right. So, and then, you're right, we square half of b, which was now 25/16. So again, we add it to both sides of the equation. Okay. Now our equation says x squared minus 5 halves x plus 25/16 equals that negative 3 halves plus 25/16. Now, they skipped a few steps here, so I'm just going to talk about it. On the right-hand side, we have a negative 3 halves plus a 25/16. We can't just add them because they're not common denominators. So we got to turn that 2 into a 16. So we got to multiply by 8, right? How do we turn halves into 16? Got to multiply by 8. So then you're going to get negative 3 halves becomes negative 24/16. Okay? So they skip that whole thing because they're like, oh, you know how to add fractions. But I want to just refresh everybody's memory, okay? And so then negative 24/16 plus 25/16 is 1/16. Okay? Because we have negative 24 of them and we have 25 of them. And then we got to separate our perfect square trinomial thingy. Okay? So remember, when you do that, it's whatever you got for half of b. That's what goes inside. Okay? So that's why the next step down in this example is x minus 5/4 closed squared equals 1/16. Okay? Because again, you put your half of b inside of your perfect square trinomial. And if you don't believe me, you can always FOIL it out. Okay? And you should get the step above. So now that we have x minus 5/4 closed squared equals 1/16, we proceed as usual. Okay? To undo a squared, we have to root both sides. So the square root of something squared is always that something. So the left side is just x minus 5/4. Okay? And when we square root the right side, it's plus or minus the square root of 1/16. Okay? Lucky for us, those are both perfect squares, 1/16. So your answer right after that is x minus 5/4 equals plus or minus 1/4, because the square root of 1 is 1, and the square root of 16 is 4. Okay? So again, x minus 5/4 equals plus or minus 1/4. And then we still got to get x all by itself, and we have this pesky negative 5/4 in the way. So you add it to both sides like usual, and you say x equals 5/4 plus or minus 1/4. Okay? So that's, technically correct, but again, I would like you to separate them like before. So x equals 5/4 plus 1/4, or x equals 5/4 minus 1/4.
I have a question.
Mm-hmm.
How do you know, so if you go up a step where it says x minus 5/4 equals plus or minus 1/4,
Uh-huh.
when you add 5/4 to both sides,
Mm-hmm.
why wouldn't it be plus or minus 1/4 plus 5/4?
Because that wouldn't make any sense. Well, let me think. Let's see if we can do it.
I mean, how do you know whether you should start with the 5/4 or whether
Well, you always put it in front. It's just the way.
okay.
You always put it in front of the plus or minus sign.
Okay. Gotcha.
Now, you can test your theory, though. You can test your theory by putting it on the other side and see what happens. It might be a math grammar thing, right?
5/4 plus 1/4 and
Okay.
6.
I mean,
So it should just be
I don't know.
Yeah, you could do plus 1/4.
You could start
Plus.
with a quarter.
Because you'd still get 6 and 3/4. Yep, hold on. 2, yeah.
Yeah, you don't do it all the way down. You can,
So yeah, I don't think it's gonna work if you do it the other way. Anyway,
Okay.
we can think about that later. That's a good question. But generally speaking, you put whatever you add to the other side in front of the plus or minus sign. And then, when you get it, 5/4 plus 1/4 is 6/4. You can reduce that to 3 halves. 5/4 minus 1/4 is 4/4, which is 1. Okay? So your solutions are x equals 3/2 and x equals 1. That's a lot of work, huh? So there's a couple key things to remember. A, divide out your a term. Get rid of it. Make sure you divide the whole equation by it and the right side too. Okay. Then do your process of completing the square. And when you're ready to put it in parentheses squared, remember that it's your b term, half your b term that you got when you completed the square. Not the square of it, but half of b that goes inside your perfect squared binomial, parentheses. Really important, because sometimes it's hard to think, wait, 5/4 or how many 26? Well, so if you don't remember, you can always FOIL it out, and if you do, you can always think it out too. Like, how did we get, what's the square root of 25/16 or whatever? So you'll have to find your own method of remembering what part goes inside the parentheses. We got one more thing to get through, and it's about I. I missed old I. It's a good friend of mine. It says not all solutions of quadratic equations are real numbers, because we learned how to find I last chapter. In some cases, these solutions are complex numbers, aka imaginary numbers, in the form of a plus bi, where of course b is not 0 because that would make that a real number. Well, let's figure out what they're talking about. So if you think about it, I has to do with negatives under the square root. Okay, so you can kind of think about what this example is going to look like. It's going to be some negative number in the square root. So let's see if my prediction is true. Equations with complex solutions, example 6. Okay. Solve x squared. Hey, look, no a term. Hooray for us. Okay, x squared plus 4x plus 11 equals nothing by completing the square. So we proceed as usual. What's b?
2.
Right, well, half of b is 2. So you're,
Yeah, 4.
so 4 and half of b is 2, and 2 squared?
4.
Right. But first I forgot, you got to move that negative 11 over. Okay? So x squared plus 4x equals negative 11, right? Because we got to get x squared plus bx. Okay? But you're right. Then so what do we do with that 4, Stormy?
Oh, plug it back in.
Nope. We got to add it to both sides. Okay?
Oh, yeah.
Because we don't plug it in yet. We don't have an x value yet. So let me repeat. When we have x squared plus 4x plus 11 equals 0, we got to move that 11 over to the other side. And then we complete the square. So then we got x squared plus 4x equals negative 11. Because we don't want that c term in our way. Okay? And you rightly said that half of b squared is 4. So then we got to add 4 to both sides. So we get x squared plus 4x plus 4 equals negative 11 plus 4. Because again, add it to both sides. Well, we got to make our perfect square trinomial. Well, it multiplies to be 2 and adds up, or 4 and adds up to be 4. Well, heck, that's 2 plus 2. So you get open paren, x plus 2 closed squared equals, hey look, a negative 7. So my prediction is turning out to be true. Okay. So open x plus 2 squared equals negative 7. To undo the squared, we have the root. So on the left side, you get what's inside parentheses, x plus 2 equals, of course, don't forget your famous plus or minus sign, plus or minus the square root of negative 7. Well, what can we pull out of the square root of negative 7, everybody? I.
Oh, yeah,
I. Because I, again, is the square root of negative 1, right?
Yeah.
And when you do that, you have x plus 2, because we haven't moved anything yet, equals plus or minus I times the square root of 7. Because we're just pulling out that negative 1. Square root of negative 1. So then finally, we got to get rid of that 2, a positive 2, because we have an x plus 2 on the left by subtracting it. You get x equals negative 2 plus or minus the I radical 7. Okay?
So your solution.
Yeah, your solution, they're not like terms. Negative 2 is real, and I radical 7 is imaginary. So your solution is just that. The first one is negative 2 plus I radical 7. And your second one is -2 minus, I radical 7. Okay? Because they're not like terms, that you're done. End. And of course you can check it, but it says, it wants you to graph it. A graph showing a related function shows that. The equation has no real solution. Now, who remembers what that looks like in Graphland? What happens if a parabola has no solutions? Yeah, Ella's right. She says it does not cross the x-axis. So that's interesting. We thought there was no solution, real solutions, but there are imaginary ones. It's kind of weird to think about, huh? Okay. So that's it. I'd like you to do the ones you didn't do yesterday, which were 5 and where is it? 5 and 11. Okay, 5 and 11. They're gonna come out a little nasty, but you'll be okay. 5 and 11, and then 16 to 19. And so 5 and 11, 16 through 19. And there, I gotta find one with I somewhere. I. There isn't any. Oh, and 36. Okay, throw 36 in there. So 5, 11, 16 through 19, and 36. I gotta give you something with I in it. And then I will stop the recording. So take its time uploading.
What was it? 5, 11,
16 through 19.
16.